Okay, so let's go through the multiple choice portion of the AP packet number 3. Number 1, it's a no calculator question, and it says, if this implicit function, and it's really important to identify that this is an implicit function, then at the point 1 comma 2, y prime is what? Well, instead of y prime, we try to think about it as dy dx. So we're taking the derivative and in terms of x. So if I look at xy squared, I want to take the derivative of that in terms of x. I want to take the derivative of 2xy in terms of x, and I want to take the derivative of 8 in terms of x. Now, because it's x times y squared, I know I have to use the product rule. So I start with the derivative of x in terms of x is just 1 times y squared, plus the derivative of y squared is 2y dy dx, because we are keeping things in terms of x, and then times x. Using the chain rule again for 2xy, what I'm going to do is I'm actually going to group these like this. So I have 2x together and y together. It really doesn't matter, but this is probably the easiest way. Take the derivative of 2x, which is 2, keep y the same, and then take the derivative of y, which is just dy dx, and keep the 2x the same. And then finally, what's the derivative of 8? Well, that's just 0. Now, at this point, it's sort of a mess, so what I'm going to do is I'm going to clean it up before I do anything else with it. So this is just y squared plus 2xy times dy dx plus 4xy, plus 2y plus 2x times dy dx, which is equal to 0. Now what I need to do is I need to solve for dy dx when I have this point 1 comma 2. Well, ideally what we should do is we should solve for dy dx here. However, it'll just be easier using algebra if we just plug in 1 comma 2 right now. So x is 1, y is 2. So 2 squared is going to be 4. 2 times 1 times 2 is going to be plus 4 dy dx. 2 times y is 4 also. Plus 2 times x is 1, or 2 times 1 is 2, and that's 2 times dy dx equals 0. If I have to solve for dy dx, first thing I have to do is I have to subtract these two things over. So I'll have 4 dy dx and 2 dy dx, which gives me 6 dy dx equals, and I subtract the two 4's over, I get negative 8. Divide and reduce, you get negative 4/3. The answer was B. Moving on to number 2. Also no calculator question. If f and g are twice differentiable functions such that g of x is equal to e to the power of f of x. As soon as I see this, something should go off in my head saying there's probably going to be some chain rule involved. Then it's asking g double prime, so the second derivative of g, which is this function over here, is equal to some function h of x, which I don't know what it is, times e to the power of f of x. Then, what is that h of x? So we're going to be looking for, okay, if we know what g of x is, and that's this guy right here, e to the power of f of x, when I take its second derivative, I'll have e to the power of x, but some sort of function as a multiplier, and that's what we're looking for right now. So let's start with g of x. G of x is equal to e to the power of f of x. The first derivative is going to be, well, e to the power of anything is the same thing. However, because I'm using the chain rule, I have to take the derivative of the exponent, which is f prime of x. Now, we're not done because this is only the first derivative. As I move to the second derivative, I'm looking at this and seeing e to the power of f of x times f prime of x, which is really telling me I'm going to have to use product rule. So let's keep this guy the same for the first try. E to the power of f of x times, what's the derivative of f prime of x? Well, that's going to be f double prime of x plus. Now let's go backwards. Let's keep this guy the same. So that's going to be f prime of x times, and now I have to take the derivative of this guy, e to the power of f of x. Well, that's what we had before. It was e to the power of f of x times the derivative of the exponent, which is f prime of x. Now, trying to clean all this up, let's see. I have e to the power of f of x right here and right here. And when I'm looking at that original problem, it's saying g prime of x, g double prime of x equals h of x times e to the power of x. I should be able to factor out an e to the power of f of x. So I'm going to factor this guy out, which I get e to the power of f of x. But what am I left with? Well, here I'm only left with f double prime of x. But here I'm left with f prime of x and another f prime of x. So really I'm left with f prime of x, but that thing squared, because I have two of them. So then, really, if I'm matching this to g double prime of x, this is e to the power of f of x times some function h of x, and that's really what I was looking for. So then I look at the options. Which one has f double prime and f prime being squared? Looking very carefully, it will be this one, D. The reason it's not B, it's because f double prime is being squared. The reason it's not C is because both are being squared. This one just has a 2 in front, and that would be wrong. And this one has no squares. Okay, moving on to number 3. Also, no calculator question. An equation of the line tangent to the graph of x times 1 minus 2x quantity cubed at the point 1 comma negative 1 is, okay, so this is not that difficult. What do I need for the equation of a tangent line? I need the slope, which is always going to be f prime of x, and I need a point, but they already gave me that point, 1 comma negative 1. So my guess is if I plugged in 1 comma negative 1 into all these answers, I would always get a true statement. So really, it's all about that derivative. So f prime of x equals, now looking at the original problem, I have x times 1 minus 2x quantity cubed. Well, that means I'm going to have to use a little bit of chain rule and product rule. Nothing too bad. What's the derivative of x? 1. Keep 1 minus 2x cubed the same. Plus, take the derivative of 1 minus 2x cubed. Bring the 3 in front, 1 minus 2x quantity squared, times the derivative of the inside, which is negative 2. But do not forget, we still have not brought back that original x, so we got to bring in that x as we are keeping it the same. And now we don't have to be we don't have to simplify this. Since we're simply looking for the slope, f prime of, well, what's the x value it states? Right here, it's stating that x equals 1. So it's f prime of 1 equals 1 times 1 minus 2 cubed plus 3 times 1 minus 2 cubed times negative 2 times 1. Let's do a little cleanup. The 1 really doesn't matter here. 1 minus 2 is negative 1 cubed is still negative 1. This will be, let's see, a 3 and a negative 2 and 1 gives me negative 6 times negative 1. This should be squared times negative 1 squared is positive 1. I'm sorry, yes. Negative 1 and negative 6 give me negative 7. So really, I only need to find the answer that has a slope of negative 7. This has a positive 7, so that can't be it. Negative 2, negative 6, positive 2. There's our answer. It's A. Alright, number 4. Let f be the function defined by f of x equals x cubed plus x. G is the inverse of f inverse of f, or G is the inverse of f. G of 2 equals 1. Well, if you remember from when we did inverses, if we're going to be looking for, if we're given a function f, and we're told G is the inverse and G of 2 equals 1, I would like to rewrite this as f of 1 equals, f of 1 equals 2. Because what it's really saying is f inverse of 2 is equal to 1. Because G is the inverse function. I could replace G with f. Now it's looking for G prime of 2. But because the original function was in terms of f, G is the inverse of f. And I should be using some sort of formula that I was taught. 1 over f prime of f inverse of 2. Well, f inverse of 2 equals 1. So this right here is pretty easy. 1 over f prime of 1. F prime of 1, well, I'm given what f is, so I'm going to find the derivative. Power roll. 3x squared plus 1. Let's plug in 1. We get 4. So the answer should be 1/4, B. Alright, last problem of the multiple choice is number 5. It's looking for the slope of the line normal to the graph. Normal, which means perpendicular, we know what we're going to have to do there, to the graph of y equals 2 ln of secant of x at this point, pi over 4. Now this is a no calculator question, so because if it was, I could just plug it into my calculator, dy dx it on the graph, and then take the answer and flip it. However, in this problem, it's not a calculator, so it's really testing us on our chain rule, our product rule, all of it. It's nested functions 2 times ln of secant of x. Well, that looks like this. If I want dy dx, keep the 2 in front. Do not let it fool you. It's just a constant. The derivative of ln, so if I'm taking the derivative of ln of, call it u, that's simply 1 over u. But obviously it's not just u or it's not just x, so I'm going to have to use the chain rule. So I'm going to write 1 over secant of x times, but now I need the derivative of secant, and this is where things get difficult. What is the derivative of secant of x? Well, I don't like secant. I like sine, cosine, and tangent, and I know that secant is the same thing as 1 over cosine of x. I could be using the product rule or the quotient rule here, but the quotient rule is a bit of a waste of time, especially when I can rewrite cosine as cosine of x to the negative first power. Now this doesn't mean inverse, it just means reciprocal, because this allows me to use the chain rule. So the question is, right now, what is the derivative of cosine of x to the negative first power? Well, I'll do this in green so you can see what this is becoming. It's going to go right here. The negative 1, that's the exponent, comes in front. Keep cosine of x the same. But the exponent has to be subtracting 1, so that becomes a negative 2. But cosine was trapped inside of this exponent, so now I take the derivative of cosine, which is negative sine of x. Okay, it is a mess. It's very tough to try to evaluate this at pi over 4 right now, so I'm going to do some simplifying. Now, some really nice things happen. 1 over secant Well, secant is the reciprocal of cosine. So 1 over the reciprocal gives me just cosine of x. This negative 1 and this negative right here, since they're both being multiplied, they cancel each other out. So then I'm left with times, now I'm going to bring this sign in, sine of x, but then this cosine to the negative second, what I'm actually going to do is I'm going to divide by that. I'm going to say cosine of x quantity squared. Now if you notice, we have a cosine on top, we have a cosine on the bottom. So therefore, let's cancel one of those out. So I'm left with 2 sine of x over cosine of x, which truly reduces to 2 tangent of x. Since I need to evaluate this at pi over 4, if you remember, tangent of pi over 4 is just 1, so 2 times 1 is 2. But the answer is not 2, because we're still looking at normal. What's the opposite reciprocal of 2? Negative 1/2.